Good day, students. So, in the previous module, we have learned about inverse function, determine the dominant range of an inverse function and representation through its equation, table of values, and the graph. So, for today's video, we'll be talking about exponential function, exponential equation, and exponential inequality. So let's have first exponential function. An exponential function is a function defined by the rule f of x is equal to a raised to x, wherein a is the base and x is the exponent. So we have two conditions for us to consider that the given function is an exponential function. So the base must be greater than 0 and not equal to 1, and the exponent must not be a fixed value. So let's try these examples. Determine whether the given function represented by its equation is an exponential function or not. So let's have number 1, y is equal to 8 raised to x. Is it an exponential function or not an exponential function? So this is an exponential function because the base here is 8, which is greater than 0 and not equal to 1, and the exponent here is x, which is not a fixed value. So let's have number 2, y is equal to 5 raised to 3x. Exponential function or not? That's correct. This is an exponential function because the base here is 5, which is greater than 0 and not equal to 1, and the exponent here is 3x, which is not a fixed value. Given number 3, y is equal to 2.5 raised to 6x. Exponential function or not? This is exponential function because the base here is 2.5 and the exponent is 6x. Given number 4, y is equal to x raised to 8. Exponential function or not? That's correct. This is not exponential function because the exponent here, which is 8, is a fixed value. Number 5, y is equal to x raised to 3.5. Exponential function or not? Of course, this is not exponential function again because the exponent here is a fixed value, which is 3.5. Last example, number 6, y is equal to negative 4 raised to x. Is it an exponential function or not? Definitely this is not exponential function because your base here is negative 4, which is not greater than 0.
So now let's proceed to exponential equality. An exponential equality in one variable is an equation having a variable in the exponent. In solving exponential equality, first you have the property of equality for exponential function. That is one-to-one property. A raised to x is equal to a raised to y if and only if x is equal to y. Let's have solving exponential equality. Let's have number 1. We have given 2 raised to x is equal to 32. Since our goal here is to have the same base, apply the property of exponential equality. Factor 32 as 2 raised to 5. Why? Because 2 raised to 5 is equivalent to 32. So our given equation now is 2 raised to x is equal to 2 raised to 5. Since our given equation have the same base, focus now on the exponent. Apply the property of equality for exponential equation. So we have x is equal to 5. Okay, so let's have another example. Let's have number 2. We have given 5 raised to x is equal to 625. Same with number 1, our goal here is to have the same base and find the value of the variable. So, factor 625 as 5 raised to 4 because 5 raised to 4 is equal to 625. So, our given equation now is 5 raised to x is equal to 5 raised to 4. So our equation have the same base, focus now on the exponent. Same with number 1, apply the property of equality for exponential equation. So we have x is equal to 4. Since we have the value of the variable x, therefore, the answer is x is equal to 4. Next, let's have example number 3. We have given 9 raised to 2x plus 1 is equal to 3 raised to 8x. Same with number 1 and number 2, apply the property of exponential equality. So, factor 9 as 3 raised to 2 because 3 raised to 2 is equivalent to 9. So, our equation now is 3 raised to 2 times 2x plus 1 is equal to 3 raised to 8x. Since our given equation have the same base, focus now on the exponent or apply the property of equality for exponential equation. So on the left side of the equation, simplify 2 times 2x plus 1, that is 4x plus 2, is equal to 8x. To find the value of the variable, apply addition property of equality. Add negative 4x both sides. So we have equation 4x minus 4x plus 2 is equal to 8x minus 4x. On the left side of the equation, 4x minus 4x, that will be 0. So our equation now is 2 is equal to 8x minus 4x. Next, 8x minus 4x, that will be 4x. So our equation is 2 is equal to 4x. Next, multiply both sides by the reciprocal of 4. So we have 1 over 4 times the quantity of 2 is equal to 4x times 1 over 4. So we have 2 over 4 is equal to 4x over 4. Simplify 4x over 4, that will be x. So we have equation 2 over 4 is equal to x. Simplify 2 over 4, that will be x is equal to 1 over 2. Therefore, the value of the variable x is 1 over 2. So, let's now proceed to exponential inequality. An inequality in one variable having a variable in the exponent is referred to as exponential inequality. So, let's proceed in solving exponential inequality. In solving exponential inequality, we have the property of exponential inequality wherein they should have the same base. So, let's have example number 1. We have given 4 raised to 3x minus 1 less than 64. For number 1, our goal here is to have the same base. So, factor 64, that will be 4 raised to 3. Why 4 raised to 3? Because 4 raised to 3 is equal to 64. So, our given now is 4 raised to 3x minus 1 less than 4 raised to 3. Since our given has the same base, focus now on the exponent. Apply the property of inequality for exponential inequality. So we have 3x minus 1 less than 3. So our next step is to find the value of the variable. So to find the value of the variable, apply addition property of inequality. Add positive 1 both sides. So we have given 3x minus 1 plus 1 less than 3 plus 1. On the left side of the given, negative 1 plus 1, that is equal to 0. So we have 3x. On the right side of the given, we have 3 plus 1, that is 4. So we have given 3x less than 4. Next, multiply both sides by the reciprocal of 3. That will be 1 over 3 times the quantity of 3x less than 4 times 1 over 3. So we have given 3x over 3 less than 4 over 3. On the left side of the given, simplify 3x over 3, that will be x, less than 4 over 3. So let's have another example for solving exponential inequality. For number 2, we have given 5 raised to x plus 1 greater than or equal to 25 raised to 2. So, same with number 1, apply the property of exponential inequality. We should have the same base. So, factor 25, that will be 5 raised to 2 because the equivalent of 5 raised to 2 is equal to 25. So, when have the same base, we can focus now on the exponent. Again, apply the property of inequality for exponential inequality. So we have x plus 1 greater than or equal to 4. Then, next step is to find the value of the variable. To find the value, apply the property of addition. Add negative 1 both sides, that will be x plus 1 minus 1 greater than or equal to 4 minus 1. So on the left side of the given, simplify 1 minus 1, that is equal to 0. That will be x greater than or equal to 3. Since we find the value of x, therefore the answer is x greater than or equal to positive 3. Next, let's have example number 3. We have given 3 raised to x greater than or equal to 81 raised to x plus 1. Same with number 1 and number 2, our goal here is to have the same base. Factor 81 as 3 raised to 4 because 3 raised to 4 is equivalent to 81. So our given now is 3 raised to x is greater than or equal to 3 raised to 4 times the quantity x plus 1. Since the given have the same base, focus now on the exponent. Apply the property of inequality for exponential inequality. So we have given x greater than or equal to 4x plus 4. To find the value of the variable, apply the addition property of inequality. Add negative 4x both sides. So we have given x minus 4x greater than or equal to 4x minus 4x plus 4. On the right side of the given, simplify 4x minus 4x, that is 0. So we have given x minus 4x greater than or equal to positive 4. On the left side of the given, simplify x minus 4x, that will be negative 3x. So we have given negative 3x greater than or equal to positive 4. Next, multiply both sides by negative 1. So we have given negative 1 times the quantity of negative 3x is greater than or equal to 4 times negative 1. So we have given 3x less than or equal to negative 4. Why do we flip the sign? Because we multiplied both sides by negative. Next, to find the value of the variable x, multiply both sides by the reciprocal of 3. So we have 1 over 3 times the quantity of 3x less than or equal to negative 4 times 1 over 3. So we have given 3x over 3 less than or equal to negative 4 over 3. On the left side of the given, simplify 3x over 3. That will be x less than or equal to negative 4 over 3. Since we have the value for x, therefore the answer is x less than or equal to negative 4 over 3.
So let us now have representations of exponential function. So we can represent the exponential function through equation, table of values, and the graph. So let's say we have an example here. F of x is equal to 3 raised to x. So from that, we can represent exponential function through an equation, which is that one. Then, for the table of values here, so it's up to you to decide the number of x values and what are the x values. So in here, I decided to have 5 x values, which are negative 2, negative 1, 0, 1, and 2. So again, for table of values, you may choose several values for x. Then, you just have to evaluate these functions of x that you have decided and then write the result in f of x row. So let's say, for example, our equation is f of x is equal to 3 raised to x. Evaluate x is equal to negative 2. So you just have to substitute all x by negative 2. So we will be having f of negative 2 is equal to 3 raised to negative 2. So apply the law in negative exponent. So that would be f of negative 2 is equal to 1 over 3 raised to 2. Then simplify the denominator. So that would be f of negative 2 is equal to 1 over 9. So let's have negative 1. So substitute all x by negative 1. So that would be f of negative 1 is equal to 3 raised to negative 1. So again, apply the law of negative exponent. So that would be f of negative 1 is equal to 1 over 3 raised to 1. Then simplify. That would be f of negative 1 is equal to 1 over 3. After completing the table of values, you can now sketch the graph of the given points for x and f of x. So plotting the points, then your graph will look like this. Second example, we have an equation f of x is equal to 2 raised to x minus 4. So for the table of values, again, I decided to have 5 x values, which are 1, 2, 3, 4, and 5. So for the table of values, let's try. Our equation f of x is equal to 2 raised to x minus 4. So evaluate when x is equal to 1. So substitute all x by 1. So your equation will be f of 1 is equal to 2 raised to 1 minus 4. So simplify the exponent. So that will give us f of 1 is equal to 2 raised to negative 3. Again, apply the law of negative exponent. So that will be f of 1 is equal to 1 over 2 raised to 3. Then simplify the denominator. Then our resulting equation now will be f of 1 is equal to 1 over 8. So again, same process for the remaining x values. This will be the results. So after completing the table of values, you can now sketch the graph of the given points for x and f of x. So plotting the points, then your graph will be look like this. So let's move on now with the intercepts and zeros of an exponential function. So to determine the intercepts of an exponential function, we let x and y equal to 0. So to further understand that, let us have this example. So let us have number 1. Find the intercepts of f of x is equal to 2 raised to x plus 1 minus 8. So let's have first the y-intercept. So to calculate the y-intercept, we let x is equal to 0. So that means we just have to substitute all x by 0. So we'll have y is equal to 2 raised to 0 plus 1 minus 8. Then simplify the exponent. So that will give us y is equal to 2 raised to 1 minus 8. So simplify, that will be y is equal to 2 minus 8. Then perform the operation. So that would be y is equal to negative 6. So again, since we are looking for the intercept, so that means we are looking for a point. So your final answer will be y-intercept is at 0, negative 6. So let us solve for the x-intercept naman. So to calculate the x-intercept, we let y is equal to 0. So that means this will be 0 is equal to 2 raised to x plus 1 minus 8. So using addition property of equality, adding both sides by positive 8, so that will give us 0 plus 8 is equal to 2 raised to x plus 1 minus 8 plus 8, so that means that would be equal to 0, so automatically cancel. So simplify, so our resulting equation will be 8 is equal to 2 raised to x plus 1. So property of exponential equation, so we need to come up with a similar base. So we will be having 8 as 2 raised to 3 because 2 times 2 times 2 is equal to 8. So that means we'll be having 2 raised to 3 is equal to 2 raised to x plus 1. So that means since we already arrive at the similar bases, so we can now focus on the exponent. So applying property of exponential equation, that will give us 3 is equal to x plus 1. So again, for us to solve for the value of the variable x, we will be using addition property of equality, adding both sides by negative 1. So that will give us 3 minus 1 is equal to x plus 1 minus 1. So 1 minus 1, that would be equal to 0, all automatically cancel. Then simplify or perform the operation, 3 minus 1, that will give us 2. Therefore, the x-intercept is equal to 2. Then, the final answer must be, your x-intercept is at 2, 0. Second example, we have find the intercepts of y is equal to 4 raised to x minus 64. So let's have first the y-intercept. So substitute all x by 0. So that will give us y is equal to 4 raised to 0 minus 64. So applying the 0 exponent, the law of 0 of exponent, that will give us y is equal to 1 minus 64. So performing the operation, subtraction, that will be y is equal to negative 63. So your y-intercept is at 0, negative 63. So that is for the y-intercept. So let's have naman x-intercept. So to calculate x-intercept, we'll let y is equal to 0. So that will give us 0 is equal to 4 raised to x minus 64. So addition property of equality, adding both sides by positive 64. So that will give us 0 plus 64 is equal to 4 raised to x minus 64 plus 64. So that will give us 0, cancel. Then simplify, this will be 64 is equal to 4 raised to x. So applying the property of exponential equation, so we need to come up with a similar basis. So the factor of 64 will be 4 raised to 3. So our resulting equation now will be 4 raised to 3 is equal to 4 raised to x. So since we already arrive at the same basis, so we can now focus on the exponent. So 3 is equal to x, so symmetric property that is still equal to x is equal to 3. Therefore, your x-intercept is at 3, 0.